Welcome to qnawire.
All right, so in this problem, initially we have a capacitor uh, whose capacitance is 20 microfarads. So C is 20 microfarads. And we also know that the initial potential difference is 800 volts. Okay. So in part A, we can determine the charge stored on the capacitor. So Q equals C times V, right? So this gives you 0.016 coulombs. And in part B, so suppose we connect this capacitor with another uncharged capacitor. So we know that the charged capacitor is 20 microfarads, and the uncharged one is 10 microfarads. Okay. So we want to find out the charge distribution on the two capacitors. So let's suppose let's call this as a C prime. Okay. So this is C, and that is C prime. And the charge is Q, and the charge is Q1 and Q2. So we can list the equation Q1 plus Q2 equal Q, right? So Q is the total charge, which is the one that we found here. And we also know that because these two, they are now connected in parallel. So in that case, the potential difference over the two capacitors are the same. So we can list another equation, Q1 over C equal Q2 over C primed, right? So by plugging the value for C and C prime into this expression, and you can solve for this Q1 and Q2. And you can obtain that Q1 is, right here, you will obtain that Q1 is 5.33 times 10 to the negative 3 coulombs. And Q2 is 1.07 times 10 to the negative 2 coulombs. All right. And in part C, so we want to know the energy, the final energy of the system. So the final energy has expression E equal half Q1 squared over C plus half Q2 squared over C primed, right? So because we already have the value for Q1 and Q2 in the previous expression, in the previous solution, I mean, so we also have C and C prime, so you can do the calculations in a straightforward way, and this gives you 4.27 joules. All right. And part D, we want to know the energy decrease if we connect the after the connection. So before we do the connection, we know the initial energy EI simply equal half Q squared over C, right? And the Q here is this one, the total charge, because we just want to figure out the energy stored in the single capacitor, right? 20 microfarads. So in that case, Q is the total charge and C is the 20 microfarads. And you will see that this value is 6.4 joules. So energy decrease equal EI minus E, right? So this gives you 2.13 joules, all right? So the energy decreases by a value of 2.13 joules.